the derivative of the natural exponential function This one is nice. The derivative with respect to x of e to the x is equal to e to the x. Okay? So if you look at the graph of the natural exponential function, it's going to look something like this. Okay, so if you plug in, if you want to find the tangent line where x is equal to 2, okay, so x is equal to 2 right here, the tangent line. It's not a very good drawing, but you get the idea. So that tangent line there has a slope of e to the second power. Okay? So anywhere on that line, if you draw a tangent line, the slope of it is going to be e to whatever power the x is. Okay? So that's a very special curve. That's why it has its own letter and its own name and everything.
So it's the same?
It's the same, yes. So let's look at some examples that have that in it. So if I have y equals 4e to the x power. Okay, so you would, if you're going to take the derivative of that, you would bring the constant out in front and then take the derivative of the function. So what's the derivative of e to the x? E to the x. Okay? If I had y equals, let's say, 4x plus e to the x. Okay, the derivative. What's the derivative of 4x? 4. Because this is to the first power, right? So 1 times 4 is 4. X to the decrease it by 1 is 0. So x to the 0 power is just 1. Okay? So anytime you have a constant times just an x, the derivative is always just going to be the constant in front. Okay, plus, and then the derivative of e to the x, e to the x. Okay, if I have something like y equals e to the 3x, okay, this gets a little bit more complicated, but the derivative is going to be the same thing, e to the 3x, but then you also multiply it by the derivative of this exponent. So what's the derivative of 3x? 3. So you multiply in front by that. Okay? Any questions on that?